Today I would like to present my master thesis with the AUSN. The title is An Ethical and Scientific Analysis of the Potential Utilizations of Nuclear Reactors for the Energy Productions in Developing Countries. And later on, I would like to go to explain to the abstracts, page number 4. In this thesis, I focus on an ethical and the scientific perspective of the nuclear energy technology deployments in the developing country. Currently, most of the developing countries, they need to increase the power consumptions and the energy securities is more important issues any others among developing countries, and as well as the increase in the energy use per capita and as well as the growth rate in the power demands is well continues to raise. So that in this case, the emissions of the greenhouse gas also by the electricity productions, it increase for the global warming is a seriously expanding issues around the world. And the result from this study, it will help how the small modular nuclear reactors utilization is beneficial for the developing countries in many perspectives of the developments, especially from the financial, technological, environmental, and the safety point of view. And next, I will go through to the chapter 1, section 1, and then later on the sessions 1.1, the developments of the nuclear energy and the generations of the nuclear reactor. First of all of the energy sources and the electricity generations technology, it has their own benefits and the drawbacks. For example, fossil fuels, particularly from the coal and the natural gas, will remain the importance. And as well as the huge growth in the electricity demands is also increasing the carbon constraints of the world. And on the other hand, from the renewable sources, is abundant and produce little, but is also no greenhouse gas. But the technology from the renewables typically provide not the base load electricity supplies, and it's currently available only for a few states. So in this regard, the nuclear power is one of the alternatives for the developing country to consider. And in the recent year, due to the situations of the risings of the fossil fuels price and the depletions of wine, it will also goes the issues to raise up relating to the climate change, and as well as many countries, they are looking for the new alternative energy. And from the electricity generations from nuclear reactor, it's increased from the 2.6 trillion in the 2008 to the 4.9 trillion kilowatts in the year 2035. This is from the estimations from the IEO. And they concern about the energy security and the greenhouse gas emissions to support by the developments of the new nuclear generating capacity. And later on, I write about in the sessions 1 for the different generations types of the nuclear reactors. As first from the generation 1, it's just only the prototype and the power reactor, and the year 1960 to the 1978. And after that, the technology advanced. Right now, currently the technology is beyond the generation 3 plus reactor design. In these papers, I focus on this advanced technology for the generations 4 reactors to be considered for the deployment of the nuclear power in the developing country. And in the sessions 1.2, I discussed about why nuclear energy in the developing country is important, and mostly from the research by the International Atomic Energy Agency. As a result of the future rapid energy demands, it will also increase mainly in the developing country, especially in the Asias, including the China and India. So therefore, these developing countries are the likely of the primary target for the long-term future nuclear power deployments. And the primary obstacle of the many developing countries is not only their lack of the financial available resources to build a large-scale nuclear reactor, which costs a lot of billions of dollars and requires several years to construct. And it will also consider the other key factors such as the construction time, the safety, and the components of the operating personnel as well. And also it includes in the constructions of the conventional nuclear reactor for the larger scale site. And another important factor is that the development and the utilizations of the nuclear power is concerned from the public assistance. And most of these public assistance I will consider in the later sessions. And another aspect for the deployments of the large-scale nuclear reactors in the developing country is from the aspect of the electrical grid with the low capacity, which are currently in the main obstacle in the developing country. And in certain countries, regardless of the populations is concentrated in the urban area or in the remote area, like in Myanmar, the grid is not well developed or robust. So in this case, SMRs, the small modular nuclear reactor, may be an alternative to their ability to use the both incremental and the distributed generation source. With these potentials, these types of new technology have to concern the security concern regarding the transports and the emplacements of the SMRs in the remote area in some developing countries. For the problem in the sessions 1.3 problem statements, in many developing countries they are experiencing the rapid growth in the electricity demands, approximately 8 to 10% per year. So is this really what to investigate the potentials of the SMR utilizations in developing countries, and as well as they have a choice to choose from the import fossil fuels such as coal or natural gas, or import from the solar or others renewable technology, or to initiate the nuclear power to meet their demand in the growth. So in this thesis, I will look at the case of the Myanmar in particular as an example of developing countries. And right now, Myanmar is one of the developing countries with continuous growth in populations and as well as the expansions of the economic growth. So as a result, it will increase yearly national power demand, as well as Myanmar exports electricity to Thailand as well. So most of the electricity generations in Myanmar is based on the hydropower for the base load use. So normally the electricity generation should not rely on one type of fuels. It will weaken the energy security of a country due to their potential challenges in a particular energy sources. Due to this one type of energy source dependence, we have to face a lack of electricity, mostly in the summertime. So electrification should be diversified in order to reduce the risk of the use of fossil fuels. So the main significance of the potentially new countries with trying to pursue the nuclear programs are very seriously constrained with a large-scale site power plant, or to invest the cost we can afford or not is and it can also operate on our local grid is the major concept to consider. And for the objective of this study is to study the potential utilizations of the SMR and the ethics of the nuclear energy technology in the developing countries. And in the sessions 1.5, for the scope of the study, I limit the 3 study scope. The first one is this study only covers the comparison between the advanced technology of the nuclear power reactor, of the small modular nuclear reactor, and large conventional nuclear reactors, focusing on the technology and as well as the design safety aspects in the light water reactor, high temperatures, gas-cooled reactor, and the liquid model, 3 types of reactors. This is why these 3 reactor types are leading to the emphasis of the light water reactor technology. And the second scope is, in this study, is only concerns the suitability of SMR, including their features, technology, design, safety, and the comparison with the large-scale nuclear reactor for developing countries from the 3 significant aspects of technology, safety, and the public concerns in general. And in the third, it also considers from the ethics, public health, environmental safety, and as well as the public acceptance and the threats in the nuclear power plants or small modular nuclear reactor. And for the hypothesis, I propose the using of these new nuclear energy technology in developing countries. SMR can become one of the alternative sources which is suitable for the developing country in comparison to the large-scale nuclear reactor or other fossil fuels. And in the sessions 1.6 for the expectations of the study, it's anticipated that the outcome of the study will be useful for the developing countries, not only to Myanmar, because it will also show how the SMR's deployment is beneficial both in financial, health, and the environmental point of view if the public and the ethical issues are sufficiently protected. And in the sessions, chapter 2, section 2 and section 2.1 is the literature's review of the histories of nuclear energy technology and the development of the nuclear reactor technology. I start my writing from the basis idea studying of the atoms of the fuel fissions and the fusions point of views, and I will goes to the nuclear reactor technology advancements in the literatures. I want to skip for these sessions because this is from the literature's review part from the previous study. And in the sessions 2.1 of the developments of the nuclear reactors, currently there's a current SMR in the table 2.1 in the page number 22. Currently there's a current SMR designs in the selected country. This table was adopted from the reference papers of the year 2012. These papers are currently working for the SMR designs in 9 countries. They are developing for the SMR's designs of their own technology based on the different types of source of nuclear source. And in the table 2.2 is the summary of the key design features of the comparisons of several SMR designs which is from the reference of the Ingersoll's 2009 paper. In these papers, they compare the different design and the type of the SMRs according to their manufacturers' books. And for the chapter 3, I'm start with the methodology and the SMR features. In the introductions, in these chapters, I would like to explain more about the methodology and the SMR features. It will be explained in the sessions 3. And for the methodology, I use this paper is for the investigations is the data and the information gathered from the various sources of articles in journal, textbooks, and the sources from the IAEA, International Atomic Energy Agency, and NEA, Nuclear Energy Agency, and as well as the World Nuclear Agency report. And after that, all of these informations will be compiled in accordance to the SMR utilizations, especially for the developing countries. And I concentrated on the SMRs by which they are operated and more proven and the reliable technology. So in these papers, I discussed the technology of SMRs based on the live water technology. And in the session 3.3, which is the discussions for the general features of the SMR, and there's categorizations of the advanced SMR according to the various technology used and the characteristics for each of the design and the technology. There's 6 types, which are the pressurized white water, advanced heavy water, and high temperatures. And in these papers, I only focus on the light water. And for the technology of the large scale conventional reactor to the small scale reactors. For the conventional scale side of scales, they use the loop type primary systems for the reactor design, and for the SMR they use the integral primary system, which means the pressurizer is inside the reactor vessels. So in this case, the reactor design is changed from the different parts to the one single modules, including the pressurizers and the control device, which is to cover the loss of coolants like in the Fukushima accidents. So this is in the figure 3.2 is the light water reactor based on the SMR design for the electricity generations from the Westinghouse and the Empower and from the NuScale. These are the prototype which is used for the electricity generations. And in comparison to the large scale reactor to the small modular reactors, the design is compact, and as well as the piping system was reduced in comparison to the large scale reactor. And for the economy of scales, this is the calculations from the reference papers. In the comparisons of the economy of scales, for the SMR constructions, it will be the reductions of at least 50% of the second SMR module. So in this case, this is a reductions of the equipment fabrications, and the installation cost is also reduced in the serial productions of nuclear plants. And as well as there's also some factors affecting the competitiveness of the SMRs to the large-scale reactor. For the first design of the SMRs, it will cost very high, but for the 600 megawatts plant type, it will also reduce the cost of the reactors. So in this case, there's several factors affecting on the competitiveness of SMR from the plant design, as well as from the multiple units, and as well as the landing count, and as well as the construction schedule, unit timing, and the design as well. So for the 1,500 megawatt power plant, the cost per kilowatt electricity is relatively low for the SMR module. There's one calculated reference as well for the individual and the cumulative type or SMR for the last case. For the design specifics for the cumulative SMR, it will only cost the 1.05. And also there's some comparisons of the previous study from the last reactor constructions and the constructions of the cumulative SMR of the constructions and the revenues. For the large scale reactor construction time, it takes around 5 years. But for the SMR module, for the 5 years, it can probably finish the 2 SMR module. In this case, the first one is already finished and running the electricity generation. So the first reactor can give the revenue back when the construction time of the small scale reactor is continuously. So after the constructions of the four module of SMR constructions, it can get the 1,012 megawatts something. So in this case, the cost for the SMR is 0.7 billion and for the LR is about 2.7 billion. So in this case, why the small one has a good advantage in the revenues as well. And in this session, 3.5 is for the opportunity and the challenges for the SMR's deployment in the developing countries. In the year around 2020, there's about 11 SMR developed in the six countries. It will be a very first kinds of a plant will run for the SMRs in their countries of origins. But they still have barriers for the small modular power plants. It will be partial solutions to provide a higher degree of the intrinsic reactor security because of the fueling or the refueling of the reactors. It could sustain to reduce and require the infrastructure effort for the recipient country regarding the nuclear fuel cycles and the radioactive waste. So however, the movement and the exporting of these kinds of reactor would require and resolving a number of important legal and institutional issues. In the chapter 4, I discussed about from the perspective of the public health and the nuclear reactors. For the safety aspects of SMR, SMRs consider the safety from the 5 different perspectives of the importance to contribute to the strong safety cultures. And the SMR, it also consider for the environmental safety and the human safety For the environmental safety, the advanced technology of SMR consider more deeply the safety of the reactor, not only in the design, but also in the environmental safety aspects, considering the radiation leakage from the piping due to the design of the reactor. Because for the large-scale reactor type, we have a different module outside of the reactor. So in this case, the piping can leak out the radiations. So and another thing is using the passive safety cultures. The SMR design is do not rely on the AC power, and it can automatically respond to the accident conditions to more surely ensures the safety of the environment and to the broader of the public health. And considering the human safety in general, SMRs require the less operator participations for both the normal state or the responding of the accidents due to their significant smaller size and the smaller design. Because for the large-scale reactor, normally the regulation is stated 1 megawatt is used to 1 person. So in this case, SMRs require less operators. And for the potential radiological consequences of any accidents, the small size has smaller than those of the existing large-scale plants due to the smaller or the as well as the SMR they use low fuel enrichments of the source. It means the radionuclide inventory is orders of the magnitude less. And the small scale, even the design is small and the megawatt for each module is small, they consider about the difference in depth, like in the large scale nuclear reactor, from the level 1 to the level 5, from the prevention of the failure. The major consideration is the loss of the coolant or the hazards by the features of the reactor designs. The module is in vessels locations of the string generators. It means the reactors, inside the reactors, there are also include the string generators with the integral design of the primary circuit. And for the level 2 of the defense in depth, it considers the detections and the control of failures. It uses the active systems of the instrumentation as well as the negative reactivity coefficients over the whole dam cycle, and it common to all designs of SMR types. And the next thing is for the role of the safety of the injection systems. It's essentially based on the water. In some cases, like examples in the iris, the functions of the safety injection is coupled with the core recovery preventions. It means the safety interventions may be passive in the iris, and the other designs of the KLT40S, the safety injections of the borate water is not indicated at all. So it means all the pressurized water SMRs incorporate with the passive retentions of the heat removal systems of the various design. And often it can be a retenant based on the natural conventions of the coolant. It's to prevent not like the accidents in the Fukushimas when the tsunami came, the reactors shutdowns and the temperatures of the reactor is goes up. So in this case, the types of the SMR technology it prevents the passive coolant system. Even the external power outage was not supplied to the reactor. The internal coolants can work in the accident case. And the design features of the pressurized water type SMR is contributing to the level 4, which means the control of the severe accidents, including the accidents of the earthquake and including the additional barriers of the possible radioactive release to the environment. And sometimes there's natural convections of water in the flat deck reactor cavity. It means the cold nuclear reactors can be middle of the pond, whereas the reactor sites. So it means that when the earthquake comes in, they have a pond. So in this case, the water can visit the earthquake system, not to harm to the direct impact to the SMR. So they will also consider these kinds of severe external accidents in the SMR technology. And as well as they have a plan for the emergencies in the case of the several pressurized water reactor types. They consider the smaller source tanks, possibly resulting from the smaller fuels inventory, because for the small megawatt productions of electricity, the source for the nuclear fuel is also less enriched, not like in the large-scale reactor. So here we can see the advantages over the large-scale reactor. For the large-scale reactor, we have different pressurizer is outside, and the main reactor module is simpler, and we have different types of cooling tower. But for the SMR size is combined into one single module, and the size is also reduced from the 60 megawatt electricity to the 300 and 335, and the size of the reactor was also scaled. For the last scale is about the 58 meter, and for the diameter of the SMR is only 25 meter. And as well as for the emergency planning zone requirement, in comparison to the last case is from the US standard is about 10 miles. We need the emergency planning zones requirements, and for the IRIS of the SMR types reactor, it needs only 1 kilometer for the emergency planning zone requirements. And as well as they have strengths of the passive safety system to cover the severe accidents and as well as the human's error. For the passive safety system, they use the accumulator and the condensations and evaporative heat exchangers, which can also the gravity can also driven the safety injection system to eliminate the cost and the others installations, maintenance, and the operations of the active safety system. And for the active safety system, it requires the multiple plants and it independence and the retardants electric power supply. But for the SMR case, it's considered for the passive safety system and the numerous reactor concepts, including the generation type 3+ concept. It is expected to find the applications in the generation 4 reactors. And for the design safety of the external events, the prototype SMR has been examined with the indicated magnitude of the safety shutdown of the earthquake that is very significantly between the 3.5 to 4.4 on the Japanese scales. It was from the Nuclear Energy Agency, and this value is generally much or acceptable value incorporated in the design of the current SMR large water-cooled reactors. But we still have a public opinions on the nuclear energy technology. So in the sessions 4.11, I discussed studying from the previous literatures and the previous research conducted by the DARO. And in a study of the year 1994, from the International Bioethics Surveys, there was a positive view of the science and the technology in all the participants of the surveys, and is perceived and increasing the quality of life by majority in all countries, and less than 10% of the respondents in all countries saw it as doing more harm than good. And after the Fukushima accident happened, a post-Fukushima survey was conducted by the ABAC research on the nuclear power plants among the Thai citizens ranging from the 18 to the 16 years old, who's living in the 17 province. Approximately about 3,800 persons are interviewed. Due to the perceptions of the Fukushima accidents, the opinions against the nuclear energy have become more negative. And for the establishment of the nuclear power plant in Thailand, only 83% of the 83% of the respondents, they do not agree, and only 70% was supported the project. And a plan to build an nuclear power plant in Thailand has been postponed due to the fears of the local people, who has awareness by the leakage of the radiations in the Fukushima accidents. So we still have negative opinions of the nuclear energy technology. And for the chapter 5, I write and discuss about the potential realizations of the SMRs in developing countries. In the electricity generation systems in Myanmar, we have we have less than 30% of the households in Myanmar has access to the electricity, and the electricity consumption is also low as per capita, and as well as the urban and the rural access to the electricity is huge, while the electrification rate in the urban area is about 75%, example in Rangoon and Mandalay. But the rural area have extremely low electrification rates, only the 16%. In fact, most of the rural communities in border areas have no access to the grid-based electricity at all. And some regions and the state, we have a high shares of the rural populations. Example, in the Rakhine, Magui, and the Yakan state, most of the professors may know about the Rohingya case. That is where the Rakhine state, and they have access to the grid-based electricity below the 10%. So in this case, energy poverty also affect the populations with access to the electricity due to the shortage and the poor reliability of the power source, and it may delays in the investments in the power infrastructures, and as well as the rapid increase in the energy demands, and we have tripled over the last decade, and it goes to the electricity shortage, about the 30% of power demands during the dry season. So the solutions of the alternative of the energy supply deliberated from the various aspects, including the energy availability, security, safety, social, economic, and the environmental aspects is important for the Myanmar as well. And suitability to the SMRs as an alternative energy source for the developing country is from the financials and the economic competitiveness. SMRs in comparison to the large-scale reactor, as I mentioned, and for the integral, modular, and the scalability, which is for the large-scale reactor, it takes 5 years continuously, and the investments have to be invested. But for the SMR type, while the second one is in construction, the first one can give the revenue back. So in this case, the SMR has more integral modularity and the scalability in comparison to the large-scale reactor. And for the grid matchings, most of the developing country, their existing grid is not really suitable for the large-scale reactor for the supply generations and the load. And for the next issues is about the site selections. For the SMR case, in the case of natural disaster happens, the nuclear reactor can be transportable from one place to another place. So in this case, for the selections of the SMRs, sometimes is really mobile for the issues of the site selections. But for the large-scale reactor, we cannot move when we have to face a natural disaster. And I just heard about the case in the Thailand where they are planning to build nuclear power plants in the industrial zone. And for the safety aspects and the loss of coolants, which is this is a schematic diagram of the power cycle of the SMR. When the earthquake comes in, the water in the pond, it prevents the direct impact to the coal reactor vessels. So in this case, the reactor is still working properly between the 3.5 to 4.4 Japanese Richter scales. So when the external electricity outage was off, the internal generator of the string generator turbine, it will work and the water will be warmed up and the temperatures inside the reactor will go down, not to happen like in the Fukushima accidents. And there is also a double layer of the water pump to prevent the earthquake. This is the external water pump to prevent in the case of the earthquake. And this is the reactor vessel. This water is when the external string generators didn't work, the water goes up due to the gravity of the system, and it will depressurize the box and it goes up and the reactor will cool down. So this is the safety aspects of the loss of coolants in the case of accident. This is in this case the reactor was underground. And also the SMR has tests for the earthquake resistance. And for the waste management, for the large-scale nuclear reactors, it needs to be a disposal of the spent fuels. But in the case of SMR, the reactors are the small reactors and they don't need the on-site refuelings. The reactor designs for the fuel will last about 10 to 15 years. And the uranium with the reprocessing of the spent fuels is really high in comparison to the other types of fuels. But in the case of the nuclear power plants, the quantity of the waste for the harmful level is relatively low in comparison to the low level and the medium level. For the operations and the maintenance, The SMR is a small size and it will be located in the remote or the isolated area. It means the physically protections will be a challenge. And to consider is the how will be the regulatories have been take care of these kinds of operations and the maintenance of the reactors. So there is a need to enhance the level of safety, and it will be one challenge for the developing country. But SMR is suitable for the developing countries such as Myanmar and Thailand from the point of nuclear electric generations. And it will also can serve as a demonstration unit for the nuclear energy to the public and the energy level of formal and the informal education as well. And the current conditions and the problems of Myanmar to build a nuclear power plants is most of the people, they do not know the type, size, quantity and the safety systems of the nuclear power plants. They only know the laws of the nuclear power plants in the country. So the main problems of the public acceptance in this society is a fear. When they heard the word nuclear, they are thinking of nuclear weapons and the nuclear explosions at the Chernobyl and the Fukushima. So as a conclusions, the SMRs might be one of the potential solutions for the baseload energy generations in the developing countries, and SMR are scalable of the nuclear power plant design, and it will promise to reduce the investment risks, and it can increment the capacity by expansions one module to the another module. And as well as the power grid in many developing countries, they could be considered with the suitable of the nuclear power plant to the SMR, not the large one. And in this thesis, I only presented about the technology and the safety and the current situations of the and the futures for the SMR. So SMR has a lot of advantages, but they have some limitations, and to consider for the SMR in the developing countries. There's 9 conclusions to consider for the utilizations of the developing country. The advantages from the design safety as well as and loss of plants, and as well as from the grid size in the case of Thailand as well, and for the site selections and the prolifications as well, and as well as the emergency planning and the waste management. These 9 aspects are the advantage to consider SMR's utilizations in the developing countries. And I still have some recommendations and the future works and some limitations to work more. From the technical assessments, it remains the critical to minimize the harms to the public and the environment, because most of them are still in the prototype stage and the commercialized. So in the futures of my PhD study, I will need to do more research on the interplay between the questions of the technology, ethics, and the public health and the environmental aspects, and to consider more detail from the public assessments as public acceptance issues associated with the nuclear power plants, and as well as the ethics on the nuclear energy. So these are my presentations for today, and I would like to thanks to the director for the time and the availability support to this thesis. Thank you so much.
Thank you. Okay, thank you, Yamin. So the floor is open for questions, comments, experience. Who would like to start? Okay, Stina, please use the mic.
just need some clarification. Are you looking at the potential or the suitability or the effectiveness of SMR? I'm just thinking because you're using these terms interchangeably, so I'm not clear which is the right term that you're using for potential suitability or effectiveness of SMR. Because from your background just now, I was made to understand that there is a demand for, there's an increasing demand for energy, and also you mentioned something like you want to reduce the dependency on what do you call
one type of energy source, only on the hydropower.
But at the same time, you say they are exporting to the hydropower. They are exporting. In other words, there is a surplus.
Actually, may I say some of the government issues? Previously, Myanmar was under military government. So in this case, the military government, the electricity is not surplus, but they want the money of the foreign income. So in this case, they trade to the electricity to the Thailand.
So in short, you want to diversify the...
Yes, diversify the energy
So now,
source.
in the process of diversification, you have chosen nuclear energy. I mean, there are questions in terms of the significance of the study. Why nuclear? I mean, knowing very well it is costly, it is technology intensive, and all that. But now you are trying to argue that nuclear can be reduced. I mean, it is scalable, it is portable, it is you can situate in any part of the country and all that. I mean, you're talking about the benefits of. So it's something. It looks like cost-benefit analysis. You know, something like. I mean, it rings to my mind that something like what you're doing is basically besides looking at the potential, suitability, effectiveness. It looks something like cost-benefit analysis of bringing in this SMR technology to developing countries, and you're using this case study. But at the same time, you're looking at the scope. I was just wondering, you're looking at the perception of the people, you're looking at the economic side of the issue, you're looking at the site analysis, you're looking at technology, you're looking at the cost. So I'm just thinking, how are you going to scope, I mean, with this broad-based analysis, how are you going to relate to the ethical question that eventually you want to focus on, that is on the safety aspect? But when you come to the safety, it appears more of a technological solution rather than it is more of a technology solving the safety issue, of course. So, I mean, it is technology intensive, definitely it is cost. I mean, it entails cost. So, I mean, as a study, do you need a study to do this? Because rationally you know that only countries that can afford technology, they will utilize this. Because you're not comparing with any other alternative source of energy, you're just looking at one source of energy. So what is there to say this technology is better? Because you're not comparing with another source. So you're just looking at the safety aspect to enable this technology to be adapted. You're not comparing with another form of energy. So I'm trying to see what is the issue that warrants this study.
In this paper, actually I compare the technology, but it's not the different types of energy source. I compare mostly the technology of the large-scale reactor technology to the small-scale nuclear reactor technology. So I limit my study. If we consider the nuclear reactor for the developing country, whether we go to follow to the large-scale nuclear reactor, or whether we use the advanced technology. If my study is, if we use the advanced technology, what will be the benefits of this advanced technology to the developing country, as in the case of Thailand or the Myanmar? So maybe
That's your scope.
Yes, that is my scope. So I will add in my scope of the study for this recommendation. Thank you so much.
Ravi?
Yeah, Yamin, can you go back to your title? Yeah, at what stage of your thesis you are now in? You are finished already, right? I have some similar question with Dr. Siva. The title here is Ethical and Scientific Analysis. So you have two. You have done the scientific analysis quite well, in fact, on the potential utilization of this. So the ethical analysis, what framework do you use to actually look at the ethical analysis? I think the UN, as a UNESCO, if I'm not mistaken, there is some framework that you apply, right? Distributed justice, in terms of safety and security. There's two elements when we talk about nuclearization or nuclear power plant. There's an element of safety, and there's also an element of security, which is actually quite different. Because one of the terms that I keep on hearing was energy security. So energy security, that's involved a process called securitization. Energy needs to be securitized in order for it to be a security issue, right? Like drugs, it needs to be securitized. But let's not go there. So I'm just looking at, because your presentation was too lengthy, so I can't really keep track. So I'm just raising this query. It's not an issue, it's a query whether you have done an ethical analysis. Scientific analysis you have compared. Alright, you're looking at Myanmar, right?
Yes.
Right. Basically it's an energy mix. It's quite straightforward. Now we look at the energy mix of Myanmar. What is the percentage of hydropower? What is that? Now then, they have not gone nuclear yet, right? They have not
Yes,
built
we have
up.
not.
Now you are looking at the consideration. What are the ethical considerations? Whether they are ethically ready, whether there is human, what do you call that? The issue that I have in my country on nuclearization is not much of public opinion solicitation.
Yes.
Nobody talks about
Nobody
it.
talk
Everybody
about
tells, the
it.
government
Yes,
tells you
yes.
it's good, it's good, it's good.
Yes.
No, it's economically, it is carbon free, you know. But nobody asks us whether we want. We don't have a choice. What do you call that? A position for energy choices like we have in more developed countries. So I'm just looking at whether you have done that work. I've not seen. I mean, I've not really read through your work. So just your feedback on this.
So Professor's question is whether I consider about the ethical analysis in this paper
Correct.
more detail. Actually, I just for the ethical issues, I just use the case from the Thailand. How many percentage has been asserted after the Fukushima? I use the previous reference because when I conduct my thesis in Myanmar, to get that kinds of survey data is difficult because
what I meant was actually what are the structure. If you could Google it, you can look. You see nuclear ethics. There are several ethical considerations when you build a power plant. One of it is public opinion solicitation. The other one, because there's an issue of nuclear waste where you have to give your children and your grandchildren the waste to take care. Whether there is an ethical concern on that. So I'm just wondering whether you have addressed those issues. I think your thesis will be stronger if you address those ethical issues that related with the building of nuclear power plant. Okay, that's fine. Whether it's a full-fledged or modular based.
I think I might lack these kinds of detailed analysis of what justifications of the ethical subcategories of the ethical analysis. I think I might lack in this paper.
Just consider that.
Yes, I will modify after the discussions to put more details on the ethical analysis.
Sorry? Yeah.
Yes, just as the professor who's sitting next to me pointed out, the waste management is one of the biggest issues concerning nuclear power generation. And I think you place much emphasis on the demand side of power generation in developing countries like Myanmar or Thailand. But well, you have to consider how people manage radioactive waste, where to place the dump of the radioactive waste, and how to deliver, how to transport the individual waste, these things. And I also think that this issue has to be considered in the perspective of intergenerational ethics, as Professor pointed out. This issue concerns the future generation of those people in developing countries.
Maybe I explain very long and I just skip something. For the waste management of the SMR, we don't need a specific disposal site of the waste from the recipient country, because the SMR is a factory produced by the company, by the country, like while they are working from the several countries of the SMR designs. Here are the manufacturers from the different country of the SMR's design. Japan is from the Toshiba.
But do you mean that those countries bring back the waste back to their own country?
This is stays negotiations of the factory and the recipient. That's why the issues I mentioned somewhere in my thesis, these are the critical issues for the developing countries for the expansions and the transportations of the waste fuels from the recipient's country. I mentioned it somewhere in the thesis, but I forgot to mention why I'm explaining it.
As a Japanese, I strongly disagree if Toshiba decided to bring back the waste to Japan.
Yeah. So for the SMR case, the refuel cycle is also longer than the LR case. So this is why there are discussions with the International Atomic Energy Agency and the manufacturers for the regulations and the regulatory controls of the waste management agreement.
So I think the issue of intergenerational ethics, maybe you need to add something on. If all human beings have equal rights, then future generations have equal rights to us and a right to a non-polluted environment. So then we have to consider the long half-life of radioactive waste if the reactor is making radioactive waste. Now, if you can create a reactor with no waste, a zero waste reactor cycle, then this would be solve the waste issue. We would just then have the risk. So, for example, a fast breeder reaction which creates more fuel than it consumes. The problem is, as far as I know, these have been very difficult to operate, but it seems like some are operating. So maybe you need something on the different types of radioisotope, and that what's being used in this fuel cycle are the small reactors using different fuel systems, and how would the developing country distinguish between these?
I will add in the later.
And the issue of whose responsibility it is for the public consensus of so we have companies in rich countries who are trying to develop, and like Toshiba, and then Tower doesn't want Toshiba to bring back the radioactive waste into Japan, but if it can be recycled into usable material, and it's then perhaps the cycle goes on for a long time. So
I will put more details of the refueling of the spent fuels, because the SMRs they are testing with the refuel pellet for the reuse of these spent fuel to the reactor again to become a spent fuel pellet project. So I will put more information on this case.
So that's the question, if technological advancement can, how it alters the ethical concerns people have.
And recently, news reported that Vietnam stopped the development of nuclear energy.
Yeah. I have a master's student who's working on that. I just wanted to say I have a master's student working on nuclearization in Vietnam. But only last week she found out that Vietnam is opted not to go nuclear. Now we are having difficulty how to write the thesis.
I'm not so sure about for the Myanmar case, but one of the academic persons who's living in the UK, and he tries to give a proposal to the Aung San Suu Kyi for the SMR proposals, and he said at the discussions at the embassy, and he said he only needs some few persons to go on the SMS project, and I have a seminar, one seminar in Myanmar in the year 2014 January with the officials and the governments of the staff who are interested in the new and the advanced technology of the nuclear reactor. But due to the changes of the governments, I don't know the current conditions of the SMR nuclear project. But at least the government's officials, they have some interest and have collaborations with the IAEA for the developments of the nuclear technology, not only for the reactor, but also for the isotopes for the health issues as well.
Usually it takes a long time, 20-30 years. When a country starts to build a nuclear power plant, you need to educate your people,
Yes.
you have enough scientists, you have technology, transfer, and that is a whole process. So it takes a long time.
Any other comments, anyone? Yes, Andrew?
I'll try to be nice because you didn't ask me anything too difficult. So, just one quick question on the intergenerational economics. On the cash outlay charts, there was no downtick at the end. So does the consideration consider the decommissioning of the plant at the end, the costs of that economically? You can search for like decommission.
You mean this card or?
The discount rate, or just like the decommissioning cost, because usually that's quite high and the burden is shifted from the
For the
private to the public.
for the decommissioning, as I mentioned, The reactor, it stays in the prototype stage, and for the decommissionations, it still have negotiations and the discussions with the company for the decommissionations of the reactors.
From negotiating. Oh,
Yeah,
thank you.
with the IE, because the economics, it is not available for the commercialized use. It stay in the research reactor stage for the developments of the advanced technology.
There's always a double jeopardy cost there. When it comes to commissioning and recommissioning, it's as expensive as building a plant as well.
Okay, well, I think, thank you very much, Yamin, for presentation. And you've got some ideas for some improvements. And I think Taro's presentation that comes next will also give you some more food for thought about nuclear power.
Thank you so much for the valuable comments and suggestions.
Afternoon is always difficult.